Hey everybody, welcome back to another Polar Devlog. It is the afternoon of Sunday, December 1st, and I'm just getting back in town today after spending about a week with my family for the Thanksgiving holiday and starting up and working on a brand new, very different project which you guys will hear about at some point in the future. That said, now that we're back in town, I'm ready to pick up where we left off on Polar just about a week ago. So at the end of the last devlog, apart from just touching things up visually and adding the background and making everything look a little bit cooler, I added this big mound of snow that the bear could slide into, signaling that you were at the end of the stage. Now looking at my Trello board, I just have one task remaining for my basic prototype milestone, and that is creating cooldowns. Specifically here what I'm talking about is a cooldown for the dashing effect, since you can dash over and over and over again and build up way too much speed right now. But I want to build this as a component where I can do other things besides dashing, maybe a cooldown for sliding, for double jumping. I want to make this a little bit modular so I can reuse it. So we're going to jump into that today. I think creating this timed functionality should be easy enough. The big challenge for me is going to be creating a little UI component to kind of show the user how much time they have left on the cooldown. I want to do something like what they have in Overwatch. So it's going to be a little square, I think, in the bottom corner of the screen with an icon for the dash skill and then a little timer to count down how much time you have left until you can dash again. First things first, before I create my UI element, I need to have some kind of icon for the dash animation. I'm not feeling particularly inspired to create something from scratch at the moment, so I think I'm just going to take an outline of the bear doing this little dash pose. We'll see where this goes. Well, I'm pretty horrified by how long it took me to make a very simple image that has ended up looking like a stop sign with a green bear on it. But for now, this is going to have to do. I'm going to export this image for use in Unity along with a grayscale version for when we're waiting on the cooldown timer to count down. Let's export those and hop into Unity. So I've just flipped over to Unity and imported this little graphic here and stuck it on the bottom of my gameplay canvas. I actually think it looks pretty cool. You can't see all the little imperfections that I was able to see while I was working on this in GIMP. Of course, nothing happens yet when you dash. I still need to code up that functionality, and that's what I'm going to work on next. So I can hear in the other room that Kate has just fired up a Christmas movie, and I kind of want to go join her and watch some of that, so I'm going to swap over from my PC to my laptop and try to make a little more progress. As an early Christmas present to myself over Thanksgiving, I actually treated myself to quite a nice upgrade from my very old 2013 MacBook Air and got the new MacBook Pro 16-inch. I'm really curious to see how it performs with Unity and just the various other tools that I do in my day-to-day dev work. Let me know if you have any questions about it or want me to test anything. I'm just really excited to use this machine. I'll catch up later once I have some more progress on this cooldown functionality. Alright, fast forward to Monday morning and I've got all that basic cooldown functionality wrapped up, and I want to go ahead and walk you through that before I head off to work. So here's what our cooldown looks like. Of course, you'll recognize our little icon that we made yesterday, and when I press D to dash, that icon will turn gray and begin to count down from 5 seconds. During that period of time, if I press D, I of course can no longer dash, and once it gets back to 0, it'll light back up again, and I'm able to dash again. This was actually pretty easy to implement, so I'm going to go ahead and show you how I did this. I'll start with a project hierarchy just to show you how I've set this up. I've got this parent game object for my UI, which contains my gameplay canvas. Now my gameplay canvas previously only contained my score text here and the timer text, but now I've got this item called Cooldowns. Within the cooldowns I have a prefab called Dash, and this prefab is where I did all the work to create this cooldown effect. The way I laid out this prefab is pretty straightforward. It started out just as an empty game object, and then I threw in an image for, of course, the cooldown image and timer text for the text that counts down as we wait for the cooldown. On this top object, I have my cooldown timer script, which takes an active sprite and an inactive sprite. As you might guess, that is the colored version of my icon and the gray version of my icon, which we're showing while the skill is on cooldown. Here is my cooldown timer component, and I have to say I'm pretty happy with how this turned out because it's just about 75 lines long and it's very reusable, and it does a good job, I think, of only touching UI. There's no business logic in here. So I'll go ahead and walk you through what I did. The most important attributes of this component are, of course, the 2 sprite images that we pass in that we're going to flip between, as well as references to the image that's actually on the game object and the timer text, and finally our stopwatch, which is coming from system.diagnostics. I think the most important design consideration here was exposing only one public function, and that is start cooldown, which requires seconds as a parameter. As I've laid out here, this function has basically 4 main requirements. It needs to set the seconds for the cooldown, start the timer, change the image, of course, to the inactive sprite since we're just beginning the cooldown, and setting the flag on cooldown to true. Now, on cooldown is the only other thing that I am exposing to the public with a computed property. Here I will allow any other class to look at this cooldown timer and check to see whether or not we are on cooldown right now. And that's what the player is going to use to decide whether or not it's allowed to dash. I'm keeping track of the countdown itself inside my update function here. If we are on cooldown and the stopwatch is running, of course we're updating the UI by calculating the remaining seconds and printing that out to our text that we have a reference to. And if our elapsed seconds have passed the seconds for cooldown that we saved from our start cooldown function, then we will stop, which basically just flips everything that we did in start cooldown, sets the flag, changes the image, and takes care of everything for us. Finally, I'll show you just how easy this was to integrate with my player controller. When the player controller wakes up, I grab a reference to my dash cooldown timer. Here in my capture input function, where I was previously just looking for input to kick off the dash, I'm now checking that dash cooldown timer using my computed property to figure out whether or not we're on cooldown. If we are not on cooldown, then we'll go ahead and request our dash state as normal. Now if I scroll down to our dash state here, when we enter the dash state is of course when we want to start that cooldown. So you can see I've added this line just here at the bottom where I grab a reference to that cooldown timer and start the cooldown using a predetermined value that I have set up here for just how long I want that particular cooldown to be. Pretty simple. Because this cooldown component itself is only concerned with UI and is totally configurable in terms of the length of the cooldown and the images, I think it'll be super easy to create a bunch of cooldowns for various actions that the bear can perform. So I'm pretty happy with how that turned out. Now it's time to head off to work, so we'll catch up soon. Good evening. It is just after work on Tuesday around 5:15 p.m. and I had a pretty productive day at work today, and somehow that always inspires me to be equally productive when I get home. So I'm going to jump into a development task. Looking at Trello here, it looks like we've pretty much finished up our basic prototype milestone, which I'm really happy about, and we get to move on to the advanced prototype. I have way more tasks that I need to put in here for right now, but for just tonight, I'm going to take off this first task, which is downhill sliding. The functionality I want here is pretty straightforward. I just want to modify the behavior of my slide state. Right now when you're walking on flat ground and you slide, you'll slow down to a certain point at which you will hop back up and keep walking. This is a little more evident if you get a speed boost from a dash and then slide. You'll see how much he slows down before he hops back up. What I want to be the case is when the bear is walking on a downhill plane, or a plane that's kind of rotated forward, he'll be able to maintain that slide indefinitely and even pick up speed based on the angle of that plane. So I think I have to do a little bit of work with collisions here to figure out what type of plane I'm colliding with, but I don't think it's going to be too tough, so we'll just go ahead and jump into it. Alright, so with just a few lines of code, I've got this kind of working, and I'll show you what I mean. The first changes I made were in my collision handling, so in onCollisionEnter and onCollisionStay. In both of these functions where I'm checking to see if we're colliding with the ground, I've added a line to grab the angle of the ground. This is the collision game objects transform.rotation.z, and I'm just saving that in a property called ground angle. Now where I'm using that is down below in my state management code. Here in execute physics, we're already doing things like applying a force for friction, but now we're applying an extra force here based on the magnitude of that ground angle. What that means is that if the ground angle is steep enough, the force that we're adding here is going to overcome the friction force, and because we're applying this in execute physics, which is called over and over again in step with the physics engine, our player will accelerate downhill if that magnitude is great enough. Perfect. So if I flip back over to Unity, you can see that I've made a little bit of change here to my prototype scene, just adding this downhill plane for him to slide on. If we go ahead and hit play, we can observe how the code changes I made affect his behavior once he's on that slope. You'll notice right away that when he crests this hill, the player's not rotating, and it's actually giving him a little bit of trouble with his collision detection, but I'll fix that later. If we go ahead and hit slide, you can see the trees disappear more quickly behind him, and he's actually picking up quite a bit of speed, which is exactly what I wanted. After about 20 more minutes, I've tried to fix the issue where the polar bear is not rotating on the downhill, and you can see I've made progress, but there's still some issues, especially with him walking. Now, if I go ahead and set a breakpoint within onCollisionEnter, You can see that I've triggered on collision enter even though I should be continuously colliding with this downhill plane. If I hit continue, he'll take another step and trigger on collision enter again. This tells me that I'm transitioning over and over again between a walk state and a fall state. You can even see with his pose here, he thinks he's falling. So what this means is that we're not really moving down the slope as smoothly as we want to be. So I'm going to have to figure out what's causing that and fix that probably next actually. But it's time for dinner. I've been working for a while now, so we'll have to take a break here and catch up later. It is Wednesday morning going on 7 o'clock, and I'm ready to talk about how I solved those defects that I introduced last night while working on that downhill momentum functionality. The first issue I had to solve was the bear's stutter step while walking downhill. Thanks to my discovery with the debugger last night, it didn't take me too long to figure out that this was being caused by my walk state applying forces to the bear only along the x-axis. However, when he's walking downhill, the bear is not traveling directly along the x-axis. So what I had to do here was multiply the bear's quaternion for his rotation by the force vector that I was applying to the bear. This effectively rotated that vector so that it was now being applied in his direction of travel, which fixed that stutter step. Pretty easy. Next up, I had to solve for this really weird behavior while the bear was transitioning between different planes. To explain what was happening here, I'm going to go over to my iPad and try to draw it. It turns out this problem was related to how I was keeping track of whether or not the player was on the ground and updating his state accordingly. This was the previous state right here. We have a box collider around the player, and we were simply checking for collisions between the box collider and the ground to determine if we were on the ground and should be walking. Here's the problem. Because I was making decisions about what state the player should be in based on those collisions, when the player collided with multiple planes at the same time and those collision callbacks were triggered simultaneously, his state was getting really goofed up, and of course it didn't look very smooth at all. My solution for this problem was to overhaul the way that I'm checking to see if the player is grounded. Specifically, I swapped out all my collision code in favor of raycasting. Now, raycasting is not too complicated. It's basically drawing an imaginary line from an origin in a direction over a maximum distance and checking to see if it hits anything. Taking this approach immediately resolved my issue. Instead of having multiple points along the bottom of the player that could detect the ground via a collision, I just have one point directly below the center of the player, which, because it's only one point, is only going to detect one plane at a time. This made my transition between planes a lot smoother and just pretty much fixed everything up. With all those defects fixed up, I think I am content with the state of my downhill sliding code, so I'm going to mark that task complete. It's going on 7:30 now, and I'm pretty happy with the progress that I made last night and this morning, so I think I'm just going to take the rest of the morning off, have some coffee, play a video game, and just decompress a bit before work. I'll catch up soon. Hey everyone, so it is about 4 p.m. on Saturday now. I had a really busy end to the week, just not much more time to work on Polar, so I think we're going to end off the devlog here. But before I do, I want to let you guys know that I just set up a coffee page. So I'll put the link in the description if you want to. You can head over there, and if you like the work that I do, the games that I'm making, and this content that I create on YouTube, you can buy me a coffee, and I'll very much appreciate it. I definitely want to be clear, though, that there will never be any expectation from me for monetary support from you guys. I do all this stuff that I do for fun. I love making games, and I love making these videos, but they do take me a lot of time. So if you just want to show your appreciation for this work, that's a great way to do it. Alright, enough of that. I'm going to wrap up the devlog here. As always, I really hope you guys enjoyed. I'd love to hear your feedback on the new mechanics we introduced. Let me know how I can improve them, build them out, and just let me know if you have any other ideas for the game. I'm really excited to be making so much progress on it. Anyways, I'll catch you guys in the next video.